Okay, we want to work this one. We want to simplify it. And that's pretty much going to be the goal here. There's a couple things we can do at the get-go. There's a secret little rule that says if you have a negative exponent, you can flip the fraction. But let's not quite work it that way. Let us instead, we're going to, what is basically distributing, we're going to distribute this negative 3 power. So everything individually is going to be impacted by this negative 3 power. So that's how it works on the get-go. Now here's the cool thing. What we can now do is multiply these powers. X to the negative 8 raised to the negative third, we multiply negative 8 times negative 3, and we end up with x to the positive 24th. Then we multiply these powers. Y to the 8 to the negative third. 8 times negative 3 is negative 24. And we'll see how we deal with that in just a moment. Finally, on bottom, we just have 2 to the negative third. Now, here's what's going to happen. This is already in fractional mode. That's fine. Anything that has a negative power is going to switch teams. So the y to the negative 24th is going to go on bottom, and that's going to give it a positive power. 2 to the negative third, starting on bottom, is now going to go to the top and get a positive power. So something like that. Now the only thing left to do, we can actually do 2 to the third power. We'll do it off to the side here. 2 to the third. That's 2 times 2 times 2, which you should quickly recognize as 8. We will recognize that as 8. So this becomes, and then I'll just write the 8 in front of the x to the 24th, because that's how we usually like it. It'll become that. 8x to the 24th divided by y to the 24th. Boom. And that's number 7. So you might have the same problem, but with different numbers. That was a good one to work. Hannah, did that make sense? Basically, the newest thing we introduced was that we would put negative exponent things on the opposite side of the fraction. That was kind of the big to-do about that. Very good, Hannah, very good. All right, let's look at number 9, and then we will look at the problem Micah requested. Or a problem, I should say. Let's use a different color. How about green? Okay, so this one looks nasty. This thing here, first and foremost, is getting hit by a negative second power. This thing is not. So here's the first thing we can do. Let's look at each of them individually, and then we will realize we're multiplying them at the end. So let's look at them individually. What's the best way to do this? How about, okay, let's look at 4x to the 4th, y to the negative 4th, all that to the negative second. We'll look at that individually compared against 2x to the negative 8, y to the negative 4. And then we'll realize that we're multiplying them after we simplify each of them separately. Once again, this negative 2 applies to every individual term. It applies to this 4. It applies to this x to the 4 power. And it applies to this y to the negative 4 power. And so we have 4 to the negative second. That becomes 1 over 4 squared. We have x to the 4th raised to the negative 2. We multiply those powers. And still on top, we have x to the negative 8 for the moment. Here we have y to the negative 4th to the negative 2nd. Negative 4 times negative 2 becomes y to the positive 8th power. The next thing we'll see, we have x to the negative 8th up here. We're going to move it to the bottom. We're going to move it to the bottom, and once we do that, it will no longer have a negative power. It'll just be x to the 8th. This 1 is no longer necessary because you're just multiplying by 1. So then we end up with this business, y to the 8th. Then we can do 4 squared. 4 squared is 4 times 4, which is 16. So all told, we get y to the 8th over 16x to the 8th, and that'll be our green guy. We're not done with it. The orange guy is going to be a little simpler. It's not being raised to any power over here. So basically, anything that does not have a negative power will stay on top of a fraction. Anything that does have a negative power will go to the bottom of a fraction. So this essentially just becomes 2 over the x to the 8th goes to the bottom, y to the 4th also goes to the bottom. And now we've simplified. Now we're multiplying these things together. Y to the 8th times 2 on top is just 2y to the 8th. 16x to the 8th. Then there's another x to the 8th down there and a y to the 4th. Now we just have to figure out, hey, what can we do to simplify that? Well, we can take it piece by piece here. Again, let's give ourselves some space. We got a lot of space to use. First, we have 2 and then 16 on bottom. That can become 1/8 basically. And the 1 won't even be necessary because there's already something on top. Next up, x to the 8th times x to the 8th, using the power or the product rule, that would become x to the 8 plus 8 power. That'll become x to the 16th power. Finally, you have y to the 8th on top, y to the 4th on bottom. You use quotient rule, and you're going to take 4 powers away from the y. But then you can completely, basically, get rid of that and just make that y to the 4th. And that should be it. Everything has a positive power now. It's on the right side of the fraction. And we did it. Colby, did that make sense? That was the problem we worked for you, Colby. Did that one make sense for you, my friend? Let me know if it did or if you have any other questions about that one. And then we will work Micah's problem that he asked about. I hope you guys have power. If you don't have power, I hope you get power back soon. And hopefully there are resources near you, places you can go to get warm, things like that, if you do not currently have power, because it is still very cold. I think yesterday it got down to single digits. I don't consciously remember a time, and I'm 31 years old, I don't remember a time that Texas ever got down to single digits. And I've been living in Texas literally my entire life. So that's just a wild thing. Hopefully we don't have to deal with this again anytime soon. Okay, Colby, I hope that made sense. Number 9 there on power rule exponents. Micah asks if we can do an example of graphing linear equations using slope and y-intercept. We sure can. Let me pull something up. Find the slope of the line passing through the pair of points, or state that the slope is undefined. So remember, slope is found by doing y2 minus y1 over x2 minus x1. Where the first point, now it's kind of hard to write small, but we'll call this x1, y1, x2, y2, so we'll do the actual calculation now. So let's see, it's y2 minus y1. It's 6 minus 9 over x2 minus x1 over 2 minus 2. 6 minus 9 is negative 3. 2 minus 2 is 0. Uh-oh, SpaghettiOs. Dividing by 0 is undefined. Thus, the slope is literally going to be undefined. Now, it asks you, is this going to be a line that has negative slope, which means it falls from left to right? Is this a line that has positive slope, which means it rises from left to right? Is this a line that has 0 slope, which means it's horizontal? Or is this a line that has undefined slope, which means it's vertical? And it's the last case, that it's vertical. The slope is not 0. Dividing by 0 does not give you 0. It gives you undefined. It gives you nothing, really. So that's a good one. We'll work a couple from this. This is a good chance to jog our memories about slope and things like that. Here on this one, we want to find the slope of this line, and all we have is a graph. That's okay. We can see that this is the point, let's see, 1, 2, negative 2, because we had to go left 2 units on the x-axis, down 1. So this is the point negative 2, negative 1. This up here is the point positive 1, positive 1. So that works. So we can graph it using, or excuse me, we can find the slope by using the y2 minus y1 over x2 minus x1. We could also just use the rise over run interpretation. We can see that this is clearly a positively sloped line because as we move from left to right, it's positive. Or as we move from left to right, the thing is on an upward trajectory. So the rise over run, it's going to run 1, 2, 3 units. So it's going 3 units to the right. Every 2 units it goes up. And it's positive because you can just see from the line it's positive. So the slope of the line is going to be 2/3. You could have also used y2 minus y1. We can do it that way. Let's see, y2 negative 1 minus 1 over x2 minus x1. You would have gotten negative 2 over negative 3. The negatives cancel out and give you positive 2/3. So either way it would have worked. Let's see. Same idea there. Here, the slope of this line, you can see that is a horizontal line. I don't even have to think about it. Slope of the line is 0. No questions asked. Horizontal line has no slope, which makes sense. It literally, you're not going up or down as you go from left to right. So that's the same as saying there's no slope to it. There's no slanting to it. So it has a slope of 0. This slope, I don't even have to think about it. It's a vertical, straight up and down line. The slope is undefined. That's some easy points right there. Now let's analyze a couple of these. This is in the y equals mx plus b form. Remember, when you have y equals mx plus b, that's called the slope-intercept form. That's the nice form because m is the slope. The number in front of x is the slope, positive or negative. And then the point 0, comma b is the y-intercept. So we can really easily figure out what the y-intercept is going to be. Now it may accept just b itself, but let's see. The slope of the line, well, 2 is in front of the x here. So the slope of the line is 2. The y-intercept, yeah, it just wants the b part, which is 3. Although to be formal, the y-intercept is the coordinate 0, comma b. So these ones are pretty straightforward. The slope, well, we got a 9 in front of the x, so 9. The y-intercept, now this is minus 1, so it's negative 1. So again, these are pretty straightforward. The slope now, negative 2/5. That means it's negative, so it's a falling line. And every 5 units I go to the right, the line falls 2 units. Rise over run. 3 is the y-intercept. Don't let this one fool you. It's got to be in y equals mx plus b form. M is still the value in front of the x. B is the other value. So this can be rewritten as y equals negative 5x plus 3. And it's otherwise the exact same thing. So the slope is negative 5. The y-intercept is 3. So they tried to deceive you. On this one, we can still figure out what the slope and y-intercept are, but we need to put it in y equals mx plus b form, which means we need y by itself on the left-hand side, then something x plus some other number. So what we need to do is subtract 6x from both sides of this equation. you'll end up with y equals a negative 6x plus 4. So the slope is negative 6, the value in front of x. The y-intercept is b equals 4. Here, y is not quite by itself. We need to divide both sides by 2. You're going to get y equals x over 2. X over 2 can be rewritten as 1/2 x. Because if you're dividing x by 2, it's the same as multiplying it by 1/2. And then there's no b, but that just means that b is really 0. So the slope is 1/2. The y-intercept is b equals 0. Now let's get to some actual graphing. See if there's any good graphing ones. Here we go. Graph the linear equation using slope and y-intercept. So let's identify the slope and y-intercept. The slope is 2, which can be written as 2 over 1. It's positive, so for every 1 unit we go to the right, we're going to go up 2 units. The y-intercept is going to be the coordinate 0, 7. And so now we take our line tool, we put our first point at 0, 7, then we go 1 unit to the right and 2 units up. So it crosses the y-axis at 0, 7, and 1 unit to the right, 2 units up. We can just do all of these. This is really good practice. This time I won't write out what the slope and y-intercept are. Let's do this one. Okay. Negative 4x plus 1. So the y-intercept is 0, 1. So grab your line tool, go to 0, 1. You can see up here what the point is that you're hovering over at the moment. So hover over 0, 1, put your point. Now we can see that the slope is negative 4. So for every 1 unit I go to the right, it drops 1, 2, 3, 4 units. 1 unit to the right, 1 unit to the right, down 1, 2, 3, 4 units to get to your next point. One-fourth x plus 3, so this thing's going to cross the y-axis at 0, 3. Then to get our next point, we go 4 units to the right, 1 unit up. It's a positive slope. So find the point 0, 3, there it is. You're going to go 1, 2, 3, 4 units to the right, and then up only 1 unit using the rise over run interpretation. So you can graph these bad boys pretty quickly. Negative 8/9 is our slope. Our y-intercept is 0, 2, so 0, 2. And now every 9 units I go to the right, it's going to fall 8 units. Fall because the slope is negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. Now we got to fall 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So just remember how positive and negative slopes work. This is a negative slope, so it's falling. Graph this linear equation using the slope and y-intercept. There's no y-intercept written, which means that secretly you can pretend there's a ghostly +0. Ooh. It's not written, but and that's a bad plus sign. This is supposed to be a plus sign. I was trying to make it ghostly. There's secretly a +0 there that is not written. So that means this thing crosses the y-axis at 0, 0. It crosses through this middle point here. And then its slope is -6/5. So for every 1, 2, 3, 4, 5 units I go to the right, it goes down, it falls 1, 2, 3, 4, 5, 6 units. And so that's a good little, I think, refresher on slope and y-intercept and how it works. What other questions? Micah, did that help you out, Micah? Let me know if that helped you out, if that covered everything you wanted to know on graphing linear equations. I think that was a really helpful review because graphing lines is going to be a major part of your exam. Again, remember your exam, check your announcements in Canvas, check your email, because I sent out an email yesterday. Basically, your exam still opens tomorrow, but you don't have to work it tomorrow. You have all the way until Sunday to work it. Now, you only get one attempt on it, so don't work it until you know this is the one attempt you're willing to do. But in case you've lost power, internet, if there's issues, you have through this weekend, and hopefully all these issues will be handled by this weekend. Hopefully all this evil snow will melt by Saturday, and then Sunday, hopefully everything's back up to normal. So don't sit down to take the exam until you feel confident you're not going to lose power or internet, because the world has kind of gotten back to normal. This is just, I've never seen this in my entire life here in Texas, this much wintry weather. Literally every single county in Texas was under a winter watch, which is very rare, especially because areas like Galveston and Houston, they're near the water, and so they normally don't get this cold. But it just happened. That's just how it fell this time around. And so we're all in this together, and we gotta help each other out. And so I postponed the homeworks to this Sunday, and I postponed, you don't have to work the exam until this Sunday at the latest. Okay, so Micah said that helped. Does anyone else have any other questions? Any other questions or things you want me to work on? Because this is your review for the exam. I will be putting this review up on YouTube later, on the YouTube channel. Hopefully you're taking advantage of that YouTube channel. The videos are pretty well labeled. You can actually find the playlist. It's the Math 0332/1332 Spring 2021 playlist on the YouTube channel, and everything should be in there in order. The dates are labeled, and so the videos are each labeled for the section that they cover. Colby asks a great question. How do we know how many hours we have done for the tutorials? So yes, remember, quick reminder, remember that you are required to have 12 tutorial hours this semester. That counts as 5% of your final grade, and you have to have them done by the time we have our final exam. Now, at the moment, our final exam, let me pull up the information. Our final exam is scheduled for February 25th, which is this next week, this next Thursday, actually. So you have a little more than a week. Basically, You need 12 hours. You can get those by going to the Academic Support Center, which obviously is closed down this week. You can also get them by working in the study plan on MyLabs Plus. You can work in the study plan. So your Academic Support Center hours, you can find that out by asking the Academic Support Center yourself. You can go in and ask them in person, or you might be able to find an email address for them. For the study plan, you should see how many hours you have in the study plan on MyLabs Plus. If you can't see that, just ask me. Just ask me via an email, and I can go in and see how many hours you've worked in the study plan. So that, Colby, should hopefully answer your question. So I'll announce more about that on Monday, but I'm glad you asked about that. So yeah, make sure you're getting those tutorial hours in. They count for a small portion of your final grade for the 0332 class. And you can use the study plan in MyLabs Plus to get those hours. So very useful. The study plan is straightforward to use. It's pretty much just doing extra practice. In fact, you can use the study plan to help you study for your exams here. For your third exam here, you can use the study plan and just kind of see how it goes. So good question, Colby. Good question. Does anyone have any other questions? Any other questions, comments, concerns? You are quite welcome, Colby. Well, you can shoot me a question. This week I decided, even though I put attendance in on Monday, I decided to go back and delete that. So I'm not officially counting this for or against anyone in terms of attendance. But attendance is, unless your financial aid depends on it, attendance is really just record keeping purposes. We're still meeting and doing lectures. So it's good that you've been coming to those if you have. And so yeah, attendance, I'm not officially counting it against you, basically. Other than that, good luck on your exam. You can start it tomorrow, but I would suggest waiting till the weekend if you don't think your power and internet will be consistent. Remember, you will use HonorLock for the exam. You'll find an Exam 3 module opening up in Canvas that will have more information for you. So unless anyone has any other questions, I think y'all should just have yourselves a great day.